Hello, it's another A-level maths video. This is a pure mathematics video based on the year 2 content. We're looking at chapter 1 of the textbook. And this video looks at section 1.2 of the book, and it's to do with doing all kinds of things with algebraic fractions. Now, before we get into the algebra, I'd like you to think about this numerical fraction example I've put on the board. If you didn't have a calculator with you, what method would you use to simplify the fraction that's there? Pause the video and have a think about it, please. Okay, let's see how we get on with this. Not the easiest of things to deal with, is it, without a calculator here? The numbers are a little bit awkward. However, if we were to do this, right, 77 as 7 times 11, and if we were to write 187 as 17 times 11, then things become a bit easier, right? Because we can see 11 factor appears in the numerator and the denominator. So if we divide top and bottom by 11, we get our simplified fraction 7 over 17 here. So that's how we might do it. The point I'm making is that when it was written in this factorized form, it was a lot easier to deal with when everything was all combined together in these numbers here. So factorizing made things easier. And that's the key really to dealing with the algebraic examples as well. We're going to have a look at this example together and you'll see exactly what I mean. We're going to be factorizing this and we'll look for common factors in the numerator and the denominator. Okay, so let's go for it. We have x squared minus 4x minus 12 all over x squared minus 4. Not obvious to see how we might cancel this down, but let's factorize it. If we factorize that numerator, becomes x plus 2 times x minus 6. You can check that later if you need to. And the denominator, this is a difference of two squares. An easy to overlook, I think, but you don't want to overlook it, because now with that factorized version, we can now see something. You can see the x plus 2 is in the numerator and the denominator. So we can divide top and bottom of the fraction by x plus 2, up with our answer x minus 6 over x minus 2. See how useful factorizing was for us there. Okay then, so here's one for you to do. I'd like you please to simplify that algebraic fraction. You might want to factorize both the numerator and the denominator and look for those common factors. Pause the video, see how you get on. So let's see what you could have done here now. Hopefully you've taken the hint that factorizing is good. Factorize that numerator, get x minus 1 times another x minus 1. You could have written that as x minus 1 all squared, of course. And the denominator factorizes to 2x plus 1 times x minus 1. And can you see that common factor of x minus 1 on the top and the bottom? Divide top and bottom by x minus 1. You have another x minus 1 which is left on the top, and then 2x plus 1 on the bottom, and there is our simplified fraction. Get it right? Now, I hope that this is making sense to you, because a lot of people, when they meet algebraic fractions like this, their instinct is to want to multiply out. But that's not a sensible thing to do. So quick question for you. When simplifying the expression which we've got on the screen there, why would it not be sensible to start multiplying things out? Based on what we've done so far in this video, what do you think? Well, hopefully you've gotten the idea by now that expanding out the brackets actually makes things more complicated and harder to see those common factors. What we want to be doing, we want to be factorizing all the way through. So a better approach to take here, rather than expanding out, would be to factorize. Let's see if we can just quickly do this one ourselves here. So I can see fraction that we've got is, we've already got some factorization going on here, so I'm not going to be expanding these brackets out. Here we've got the 3x squared, which has already been factorized here, but I've got a quadratic factor here which I could be factorizing as well. So let's see if I can factorize that quadratic expression in the denominator. And I think it becomes 2x plus 3 multiplied by x minus 2. Let's just quickly check. Yep, I think that works. So what I can now see is I can now see a bunch of stuff in the numerator and the denominator which we can divide top and bottom by. I can see this x minus 2 is appearing in the numerator and the denominator. When I divide top and bottom, they'll both just go. I can also see x here, which is going to divide by one of the x's here as part of the x squared. So I can divide by that x, and I can divide by one of those x's there. And I'm just left with 1 in the numerator of the fraction there. So my final answer here might be 1 over 3x times 2x plus 3. Right, let's start doing some calculations with algebraic fractions then. So here I've got two fractions, one divided by the other. We'll have a look at this together as an example. But I want you to always remember to think about factorizing things where you can, so things will combine together, and you'll see things combine together very nicely once they are factorized. Okay, let's have a look at this one together then. So we have 5x squared over x squared minus 9. Now dividing is the same as multiplying by the reciprocal with fractions, right? So I'm going to multiply by the reciprocal, which is 2 lots of x plus 3. Notice I'm not expanding out that 2x plus 3 there. I want to keep things factorized where possible. And that's going to be over the 3x cubed. Okay, let's bring things together into a single fraction here. So 5x squared times 2 is going to be 10x squared, and we have this x plus 3 lurking around here as well. Now, in the denominator, hey, have you spotted something here? This is another difference of 2 squares, right? So we should factorize that. So we've got 3x cubed, and then the x squared minus 9, write that as x minus 3 times x plus 3 when we factorize that difference of 2 squares. And now look, we can see things which are going to cancel out in the top and the bottom. See an x plus 3 in the top and the bottom, divide top and bottom by x plus 3, those are going to go. I can see an x squared on the top, and I can see an x cubed on the bottom, which will have an x squared lurking within it. So divide top and bottom by x squared, those are going to go, and then I'm going to be left with x to the power 1 there. And I think that's pretty much all I can see. So let's now just write down what we've got. 10 is the only thing left in the numerator. We've got 3x times x minus 3 in the denominator, and there is my simplified fraction. Here's one for you to do then. So see how you get on with this one. We've got two fractions dividing by each other. What you need to do, of course, is factorize, 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 and see what cancels out. Over to you. Okay then, let's see how you got on. Do you agree with my answer here? So I've already made a start to write down my answer. All I've done so far is I've just changed the dividing to multiplying by the reciprocal. So what I want to do now is I want to see if I can factorize each of the things I've got here. The x squared plus 3x plus 2, I think we can say that's the same as x plus 1 times x plus 2. And then on the bottom of this fraction here, I think that becomes x minus 1 times x minus 2. Okay, so I'm going to multiply that, and I'm going to put it all together in the same fraction now as well, by the factorized versions of what we've got over here. I think the numerator of this fraction becomes 2x minus 1 times x minus 1. And then the denominator of this fraction, I think, becomes x plus 1 times x plus 3. Hopefully you agree with that and you follow what I've done there. I've done a couple of things together in that line. I've put them together in a single fraction, and I've factorized. Okay, so it looks pretty complicated, but actually the factorization has made things very nice for us, because I can now see, well, this x plus 1 appears on the top and the bottom. If I divide top and bottom by x plus 1, they're going to go. And I can also see an x minus 1, which appears as a factor in the numerator and the denominator. So divide by x minus 1 on the top and bottom, they're going to go as well. I'm pretty sure, looking at what I've got left, that I don't have any other common factors which I can cancel. So let's just write down now the answer, the simplified answer, which must be x plus 2 times 2x minus 1 on the top, and x minus 2 times x plus 3 on the bottom, and that's as simple as I'm going to get it. Okay, so these can get a little bit complicated, but as long as you keep factorized things, keep things in a factorized form, then things should work out for you. We need to cover adding and subtracting fractions in this video. And what I'd like to do is I'd like to go back to a numerical example to highlight another key thing, a key useful fact for us when we are dealing with the algebraic versions of. Have a look at the question on the screen here. Nice simple numerical fraction here. Now, what a lot of people do when they are adding together fractions without a calculator is they would find a common denominator by multiplying those denominators together. Why would that not be the most efficient approach to start by doing that for this particular example? Have a think about that and restart the video once you've done that. Okay, so as I said, this is the sort of thing where a lot of people, they would be looking at finding that common denominator to be able to add these two fractions together by just multiplying the 4 by the 6 here. Perhaps that's what you do yourself. And then you say, okay, multiply top and bottom of this one by 6. 1 times 6 is of course 6. And then multiply top and bottom of this by 4. And then we end up with here 10 over 24. So why is that? Why am I saying that's not the most efficient approach to take? Well, look, instead of multiplying these two numbers together, these two denominators together to get the common denominator, I could have done this. There's a simpler common denominator here. If we just multiply the top and bottom of this one by 3 and the top and bottom of this one by 2, we get a simpler answer. And the reason why this works is because actually these already share a factor, and that factor they share is 2. We don't need to multiply by another factor of 2 by kind of multiplying those two things together. So with that in mind, I'd like you to consider the question which is on the screen here. This is an algebraic example again. We're going to do subtraction here, but same idea, right? We need to find that common denominator. What would be the best choice out of the 3 options I've given to you there for the common denominator? Pause the video, have a think about it, and restart when you're ready. Okay, let me tell you what I think the best choice is here. I think the best choice would be the middle of those 3 options there, 5 minus 2x times 6 plus x times 1 minus x. The first one clearly is not going to work, is it? Because if we wanted a common denominator of just 5 minus 2x, we'd have to divide top and bottom of that first fraction by 6 plus x and divide top and bottom of the second fraction by 1 minus x. But we can't do that because those things don't exist on the top of those fractions. So that one's no good. The third option there, well, that would be what we would get when we just multiplied those two denominators together. But that's made things more complicated than they need to be, in the same way that making the 24 here in our previous example was more complicated than it needed to be because we only needed 12. If the two denominators already share a factor, you do not need to put that factor in more than once. That's the key idea here. So this is the best choice. So with that in mind, let's see if we can finish off this video by you expressing the following sum on the screen there as a single fraction. Try and find the most efficient common denominator to use these, and also make sure that factorized is better than expanded when you're dealing with algebraic fractions. Over to you, see how you get on. Okay, ready to do this one then? So here is the question. I've written it down here. Now, let's see if we can find our common denominator here. And I'm not going to multiply these two things together. That seems a bit silly. We're going to end up with something quite complicated there. Instead, I'm going to look for common factors that are already there by factorizing this denominator here. So we're going to end up with, in that second fraction, a denominator of, I can see that 2 and x I can pull out as a factor. I think we end up with 2x plus 5 as the other factor here. Hey, that looks promising because 2x plus 5 is now a factor of both of these denominators. So what that must mean now is that I can just get my common denominator of 2x plus 5 by multiplying top and bottom of this fraction by 2x, with 3 lots of 2x here. And then I don't need to multiply top and bottom of this fraction by anything because I've already got the denominator I want. So that's just going to be an x minus 7 like that. Okay, so now let's just collect terms together. 3 times 2x is 6x, plus another x gives us 7x. And then I've got a minus 7 there as well, all over 2x times 2x plus 5. Do you agree with my answer? Hope so. And we have reached the end of the video. Okay, hopefully that was a useful thing for you to be doing here. I'm sure that you've seen algebraic fractions before, maybe not quite as complicated, and maybe this idea of factorizing is something which has passed you by possibly before now. Anyway, a bit more consolidation practice for you if you look at exercise 1b and exercise 1c of the textbook. But please make sure that you are really, really good at these skills here with algebraic fractions, because we're going to be sort of moving on and looking at algebraic fractions a bit more for the rest of the chapter.